Voyager 1. It was launched on September 5, 1977, a true product of its era. Its mission was to explore the gas giants, Jupiter and Saturn. Voyager 1 was crafted to provide our first close-up views. It was constructed to endure the rigors of space, engineered to transmit data over vast distances, a true marvel of human creativity. The potential benefits, even greater. Its voyage is a reflection of our own. The primary mission of Voyager 1 was a spectacular success. It provided humanity with its first detailed views of Jupiter and Saturn. In 1979, Voyager 1 swept past Jupiter. It revealed the planet's turbulent atmosphere in stunning detail. The Great Red Spot, a storm larger than Earth, was seen with new clarity. We discovered active volcanoes on Jupiter's moon Io. This was a groundbreaking find. It was the first evidence of active volcanism beyond Earth. This discovery reshaped our understanding of planetary geology. After its Jovian encounter, Voyager 1 headed for Saturn. It arrived in 1980. The images it sent back were equally, if not more, breathtaking. Saturn's majestic rings were revealed in all their intricate glory. Thousands of individual ringlets were observed. Complex structures like spokes and braids puzzled scientists. Voyager 1 also studied Saturn's largest moon, Titan. It found evidence of a thick, nitrogen-rich atmosphere. This atmosphere was even denser than Earth's. This made Titan a prime candidate for further study. The Grand Tour concept was elegant. It relied on gravity assists. Each planetary flyby gave Voyager 1 a speed boost. It also altered its trajectory. This celestial slingshot was crucial. The encounters with Jupiter and Saturn fundamentally changed our view of the outer solar system. A true pathfinder. Attached to the side of Voyager 1 is a unique artifact. It is the Golden Record. This is a phonograph record made of gold-plated copper, a message in a bottle cast into the cosmic ocean for any extraterrestrial civilizations that might encounter it. It portrays the diversity of life and culture on Earth, a snapshot of our world in 1977, curated by Carl Sagan, a visionary astronomer. It includes 115 images, depicting scientific diagrams, human anatomy, animals, and landscapes. Spoken greetings in 55 languages. A collection of music from various cultures and eras, from Bach to Chuck Berry. Natural sounds of wind, rain, and human laughter. It acknowledges the possibility that we are not alone. The chances of interception are small, but the symbolic value is immense. After completing its planetary mission, Voyager 1 embarked on a new phase. Its extended mission, the Voyager Interstellar mission. Its trajectory took it towards the edge of our solar system. On August 25, 2012, a historic moment occurred. Voyager 1 crossed the heliopause. This is the boundary where the sun's solar wind is overcome by the interstellar medium. It officially entered interstellar space. This made it the first human-made object to do so. A monumental achievement. It was now sailing in the vast expanse between the stars. Operating a spacecraft in interstellar space presents unique challenges. Voyager 1 is currently over 15 billion miles, or 24 billion kilometers from Earth. At this distance, radio signals traveling at the speed of light take more than 22 hours to reach us, and another 22 hours for a response to travel back. This means commanding the spacecraft requires immense patience. Despite its age and the harsh environment, Voyager 1 continues to function. Its instruments still collect data about the interstellar medium. It measures cosmic rays, magnetic fields, and plasma density. This information is invaluable. Voyager 1 is our farthest scout. Its journey is far from over. For decades, Voyager 1 faithfully transmitted data back to Earth. Its signals, though faint, were consistent. They provided a steady stream of information from the interstellar frontier. Then, in late 2023, something changed. The communication became erratic. The telemetry data from the spacecraft's Flight Data System, or FDS, was no longer coherent. Instead of understandable engineering information, NASA's Deep Space Network began receiving a garbled stream. It was a repeating pattern of ones and zeros, or otherwise jumbled code. This was not the normal language of Voyager. This was a troubling whisper, a sign that something was seriously wrong. The Flight Data System is crucial. It gathers information from the science instruments. It also collects engineering data about the health of the spacecraft. It then bundles this information into a single package for transmission to Earth. If the FDS is not working correctly, Voyager 1 effectively becomes mute. Or worse, it speaks in a language we cannot understand. The initial detection of the anomaly sent ripples of concern through the mission team. This was not a minor glitch. It pointed to a potentially significant problem. The mysterious signal from Voyager 1 caused considerable alarm. The dreaded aspect of this situation was multifaceted. Firstly, there was the immediate fear of losing the spacecraft entirely. If the FDS problem was a symptom of a larger, cascading failure, it could mean the end of the mission. A mission that had become a symbol of human endurance and exploration. This would be a profound loss, not just scientifically, but emotionally. Voyager 1 is a part of our collective story. Its silence would be a heavy blow. The team worked tirelessly to understand the garbled data. The initial diagnosis pointed towards a problem with the FDS memory. This system is vital for formatting and sending data. Engineers suspected that a small portion of its memory had become corrupted. This corruption could have been caused by a high-energy particle strike, or it could be due to the simple degradation of aging hardware. After all, the components are nearly 50 years old. They have operated in a harsh radiation environment for decades. The dreaded confirmation was that a critical component was indeed failing. The problem with Voyager 1's flight data system sparked intense scrutiny. Experts in spacecraft engineering and computer science weighed in. The consensus was that this was likely an age-related failure. The probe has far exceeded its original design life. Its components are operating in an environment they were not fully tested for. Interstellar space is cold. It is filled with radiation. Over time, this takes a toll. The FDS memory chip failure seemed to be a classic case of hardware degradation, a confirmation that even our most resilient explorers are mortal. This is a dreaded, yet expected outcome for such long-duration missions. The challenge for NASA was immense. How do you patch software on a 1970s computer system billions of miles away? The engineers had to meticulously craft new code. The process was slow and methodical. The recent signal anomaly from Voyager 1, while concerning, does not diminish its extraordinary legacy. Even if this marks the beginning of its final chapter, the mission is an unparalleled triumph. It has fundamentally reshaped our understanding of the solar system. It has ventured into interstellar space, a feat once confined to science fiction. The data it has collected over nearly 5 decades is a treasure trove for scientists. It will be studied for generations to come. Its journey has inspired millions. It has shown us what humanity can achieve when it reaches for the stars. This is a legacy that is already secure. The dreaded confirmation of an aging system's failure is a reminder of the finite lifespan of all machines, even our most celebrated ones. Voyager 1 will not last forever. Its power source is slowly decaying. Its components are wearing out. Eventually, it will fall silent, but its journey will continue. It will drift through the Milky Way galaxy for eons, carrying its golden record. A silent ambassador from a distant, curious species, its physical journey will outlast us all.